Hello friends, the topic we are going to treat today is Boyles Law and its applications. It is a law that shows the relationship between volume and pressure of a given gas. Alright? And it was first stated by a well-known scientist, Robert Boyle, in 1662. Alright, let's just consider the statement as it was stated in the first place. So Boyles Law states that okay, the volume of a given mass of gas, is inversely proportional to its pressure, right? Provided that the temperature remains constant. Okay, temperature is a factor, pressure is another factor, and then volume is another factor. So what Boyles Law says is that the volume of a given mass of gas is inversely or indirectly proportional to its pressure, provided that the temperature and some other physical quantities remain constant. Mathematically, we can state that as false. Mathematical statement of Boyles Law is mathematically we have V, okay, is inversely proportional to P. All right? That's the mathematical statement, the first statement of Boyles Law. Right? We call this relation 1. Relation 1, okay? From here, we can get another relation. We change the sign of proportionality, introduce an equality sign and a constant. So two factors here, or rather two quantities we are going to introduce. Proportionality sign has to be changed to equality sign, and then an introduction of a constant. Now we have V is equal to, this time around, K over P, right? Okay? We call this relation 2. Okay? We call this relation 2. Alright. The next thing, we look at how we're going to arrange this. It becomes a simple cross multiplication here for us to make K the constant, the subject of this relation. We have V, or rather PV, okay? We have let's use PV, okay? PV is equal to K, right? That's what it means, okay? Where V, okay, implies the volume at pressure P, okay? Okay, so that's what it means. And then K implies proportionality constant. K implies a proportionality constant. Alright? Proportionality constant or constant of proportionality. So that is it. Either you call it constant of proportionality or proportionality constant. That's the meaning of K. V is volume at pressure. Alright? P, if you like, then K, proportionality constant. Alright, from there we call this, we can as well call this relation 3. This should be called relation 3. Okay? From relation 3 we are going to develop relation 4, which is P1 V1 is equal to P2V2. But before that, before we delve into proper explanation of the fourth relation, this is fourth relation, we need to understand what actually happens here. What this means is this, is that the product of pressure and volume of a given gas is always constant. The implication of this statement is that if the volume increases, correspondingly pressure is decreasing. If the pressure increases, correspondingly volume is decreasing, and vice versa. That is it. Alright. Now from there we have this. This simply means P1 and then V1, product of initial values of the gas, okay, and the final values of the gas. At initial point, the volume V1 stands for initial volume of the gas, while P1 stands for initial pressure of the gas. Then P2 stands for final pressure of the gas, while V2 stands for final volume of the gas. Alright. Having said that, we are going to quickly look at a simple exercise, how this Boyles Law mathematically can be applied. Alright? Boyles Law application. Alright? So we have this as an exercise. We have this, maybe we call it exercise 1. Okay? Just leave it as an exercise. A certain gas of volume 385 cubic centimeter has a pressure of 775 millimeter mercury. Alright. If the pressure of the gas is 750 millimeter mercury, calculate its new volume. That's the question. So we start with initial volume V1 is given as 385 cm cubic, right? Right? Okay, that's the initial volume. Initial pressure is given as 775 millimeter mercury, right? Okay? Then final volume of the gas is given as unknown. We don't know the value of the final volume of the gas. The next one we're going to consider is the final pressure of the gas is given as a 750 millimeter mercury, right? Okay. So these are the parameters that the question contains. The next thing is to apply. That's the meaning of Boyles Law, okay? Okay? Boyles Law. Apply. So, it's to apply Boyles Law, which is the formula here is going to be, the formula here becomes P1 V1 is equal to P2 V2, okay? Right? So this is V1. This is V1, okay? P1 V1 is equal to P2 and then V2. So we are looking for V2. We make it the subject of the formula. V2 is equal to P1 V1 all over P2. So as it is, we have made V2, that is the final volume of the gas, as the subject of the formula, or the final as the subject of the relation. So we are going to use this. and then substitute these values accordingly and arrive at the final answer. So let's do it this side. Let's do it this side. Okay, V2, which is the final volume of the gas, is giving us P1V1 all over V2, all over P2, okay? All over P2. So we substitute accordingly. We have, what do we have for P1? P1 is 775. V1 is 385 all over. P2 is 7. P2 there, as you can see, is 750, right? So if we juggle out this, we are going to have V2 is equal to 397 cm cubic. So that is the final answer. You can see from Boyles Law statements, mathematical representation of it, then all this down to the application. So this is the final answer to that question. The next thing we're going to quickly consider here is maybe 2 or 3 graphs that represent Boyles Law. Okay, so let's look at graph. Okay, all right, the first one, I, all right, is this. When V, the volume of the gas, when V, the volume of the gas is plotted against the inverse, pressure inverse, okay? You have a straight line characteristics, okay? That's it. Remember, this is the origin, okay? So that is it. Then the next one is I hope this will be clear somewhere here, right? So I'm taking this section, okay? II is another graph that when P, the pressure of the gas, okay, is plotted against the inverse, volume inverse, what do we have? We have another straight line, okay? So that is it. That is it. Very simple. So these are, there is another graph anyway, which is given as the third one, if we should see it. Okay, so we have volume, pressure once again, and this one is in this form, it's a curve, okay? All right, so that is it. We have successfully explained Boyles Law and its applications. Yeah, we can still use this as a basis, okay, to solving many other questions or challenges coming from Boyles Law. All right, thank you so much for your time, and I want to encourage you to subscribe to our YouTube channel, Levi Kingsley. Like us on Facebook, follow us on social media handles such as Twitter, Instagram, Pinterest, Reddit, like it, and you see many more of these. Thanks once again for